Hello students, myself Ms. Amruta Zadhav and I am welcoming you all to part 8 of series of chapter Superposition of Waves. So as you all know that in 7 parts we have covered most of the points in which we have done the most important term, which is superposition of waves. Then after that we have studied about the vibration in pipe, which are of two conditions: open at one end and close at one end, and even open at both the ends, right? Quickly after that we have also studied about vibration in string when the string is attached to both the ends, and after that we have studied about the vibration laws, which depending on the formula, which is n is equal to 1 upon 2l under root t by m, where L was length, T tension, and M is mass per unit length of that string, right? So after doing all of this, we are here with the part 8, in which we are going to study about the same concept but by applying to one of the apparatus which is there in your laboratory and which is known as sonometer. So in this particular part we are going to study about sonometer. So here you can see all about sonometer. So what is exactly sonometer is and how it is made? How does it look? So answer for this question is here. You can see over here it looks like this. So after looking at this, you will come to know that it is some kind of a box which is actually known as sound box. It is made up of wooden. Alright, so here you can see it is a box on which two pulleys are there. Here these are not pulleys, these are two bridges, and it is also made up of wood, and it has knife edges at the top of this. Here at the top they have knife edges, alright, and these are movable. This is nothing but a tuning fork by which you can vibrate the string which is here. You can vibrate the string with the use of this tuning fork. Tuning fork is nothing but by using which we can create vibration to the another thing, and it has various of frequencies. Okay, we are having a set of tuning fork in our laboratory in which you can take any one of them to vibrate the string, and by using various of this you can apply some kind of laws to this. Okay, so let's see what exactly happens over there. So as you can see in the diagram, it is a sound box. These are the knife edges P and Q. Okay, then T is nothing but tuning fork, and here is the hook by which a wire is attached. It is of metal wire. Okay, so as you can see over here, the wire is stretched along the knife edges and it is going on the pulley, and then at the end it is having some kind of tension. Okay, so it is slotted weights over there. Alright, and this all setting is nothing but sonometer. Okay, now what is the role of each of this? So as you can see over here, it is consisting of a hollow rectangular wooden box which is known as sound box. The sound box is used to make the larger mass of air vibrate. Now what exactly happens inside this sound box? You can see over here there are two holes. Here there are two holes through which air can blow, and when this air is blowing through sonometer, it creates some kind of vibrations. Okay, so waves are producing inside it. So it gets amplified. That string will get amplified which is there on the knife edges. Okay, the same principle will be applied which is there to apply it for the string instrument like guitar and then violin. When we plug the wire which is there on the guitar or tanpura, what happens? It creates some kind of soothing sound, right? So the same thing happens in this sonometer. Okay, then there are two bridges P and Q which are along the width of the box, which can be moved parallelly to the length of box. Okay, and another one thing which should be added in this is, on the sonometer you are having a meter scale on that. Why there is a meter scale? To measure the vibrating length. As you move the knife edges, or as you move the bridges, so you can measure the length between the two bridges, which is nothing but the vibrating length. Okay, this part will be going to discuss in later. Let us see what is next. Again, the metal wire, which is having uniform cross section and which is along the box, and it is crossed over the two bridges and then over the pulley, and at the end of it we are going to attach weight to it. Okay, a hanger with suitable slotted weights can be attached to the free end of wire. Okay, now by changing weights, the tension in the wire can be varied. Obviously, what is tension? Tension is nothing but T is equal to M into G. So as you change mass which is there on the weight or slotted weight, what we are saying, if you change this T will goes on changing. Okay, so if you wanted to change the tension of the string which is applied to it, you can change the weights. The movable bridges allow us to change the vibrating length. So what terms you can change inside sonometer? First term that you can change is tension, and second thing which you can change is vibrating length. So these two things are changeable. And what thing you cannot change? First one is nothing but mass per unit length, that you cannot change, because there is a single wire which is cross over the pulley and cross over the bridges. So this is the single wire, so you cannot change the small m, which is mass per unit length. Okay, now you can have a question like, as the L is varying, M can also be varying, but no, this L is nothing but vibrating length. And when we are discussing about mass per unit length, this is nothing but length of the wire. Okay, this is different, and capital L is different. All right, so both the length are different. That's why we are saying one as vibrating length and another as length of the wire. Okay, so let's move toward, as you can see the diagram over here. I hope you understood. If you remember, even we have already shared sonometer 1 and sonometer 2 experiments with you. Even today sir will introduce you with the sonometer 2 experiment. All right, so we are going parallelly with the theory as well as with the experiments. Okay, so you have to, or you will come to know the exact idea about it. So let's move towards the next slide, in which you can see over here. Now, as you have seen the construction of sonometer, now many of you have question like, how does it works? What kind of principle is applied to this, and how it can be worked by our side? All right, so let's see how it works and what kind of principle is exactly applied to sonometer. So here is the answer. As you all know that the chapter deals with the stationary waves, right? So even in this, stationary waves are produced between the two bridges. How stationary waves are produced? As you all know that in stationary waves, two kinds of waves should be there, which should produce in opposite directions, right? So if you plug the wire which is there on the sonometer in between, what will happen? It will create some kind of loop, obviously, if you plug it. So when you plug at midway, it will create loops. That means they are producing some kind of waves, and that waves are nothing but transverse waves. So if I plug that wire which is there between the two bridges, which you can see over here. If I plug over here, so what will happen? The loop will create between two bridges like this. Between the two bridges, it will create some kind of loops. So this wave will go towards this bridge and again it will reflect back. So in this way you can say that two waves which are opposite in direction will create stationary waves, obviously. So as stationary waves are produced over here, there exists a superposition, right? So thus the portion AB of the wire between the two bridges P and Q is nothing but vibrating length. Okay, so the vibrating length can be measured only when the two bridges are moved. Okay, so even wire can be also made to vibrate by holding the vibrating tuning fork near it. If you can vibrate the tuning fork by striking it on rubber pad and then towards the wire, what will happen? It will give the vibration to the wire, obviously, and even it will create vibration inside the string. If I am not plugging that in between, if I directly gives that wire in contact with the tuning fork, even then also vibrating will create it, or vibration will create. Now, as you can all know that this tuning fork is having different frequencies, right? So we can apply the different frequencies to the sonometer and we can get the different readings also. So the frequency of vibration as the frequency of vibration becomes same to the tuning fork, what will happen exactly over there? Again I will ask, if the frequency of vibration will become equal to the frequency of tuning fork, that means natural frequency is equal to applied frequency. What exactly happens? We have already seen this. This is known as resonance. Okay, so when the natural frequency becomes equal to frequency of the tuning fork, then it will create a resonance over there. But how we can come to know there is existing of resonance? So answer for this question is in the next slide. How to identify the resonance? Yes, we can see, or we can say that there exists an resonance inside it because the tuning fork, frequency of tuning fork may become equal to the natural frequency of the wire. But how to identify? Now, to identify the resonance, we can put a paper rider. A small piece of paper can be placed on the wire, and when you are giving a vibration to the string, then what will happen? At the maximum amplitude, that means when natural frequency becomes equal to the frequency which is applied to it, when both frequency becomes equal, it creates maximum amplitude, maximum vibrations. So at maximum vibrations, that paper rider will flies off. Okay, so it will flies off. When it will flies off? Only when the frequency which is natural and artificial frequency matches. Now how to get matches both of them? When you are going to apply a tuning fork or vibration of tuning fork to wire, not exactly wire, what you are going to do is we are going to strike the tuning fork on rubber pad which is given to you. Then you are going to touch this stem on the sonometer box. Okay, so when you strike at it on rubber pad, then you are going to keep that tuning fork on sonometer so that it will create vibrations all over the sonometer, and then when it creates vibration, that wire will get vibrate, and in certain length that paper rider will fall off. To find out that certain length, we have to move the bridges. Okay, so you have to adjust the length which is AB by moving the bridges all over the sonometer. At certain length, that paper rider will fall off. When it fall off, again when the resonance is created, only then and only at that length the paper rider will fall off. So this is the exactly principle which is there in sonometer. Actually, it is very easiest experiment of your standard. When you are going to enter the laboratory, we are going to perform this experiment, and then you will understand all of this when you are going to exactly perform that. Okay, so don't worry. Now we are going to remind something that we have already learned in the previous video. What we have learned while we are studying vibration inside a string, we have already studied about law of length, law of tension, and law of linear density. What was that? Let's see. First, we will see one by one, and the first one of them is law of length. What is law of length? I will in short will tell you that n is inversely proportional to L. That means frequency is inversely proportional to length of vibrating string. Now, as we are going to do the relation, or as we are saying the relation between two terms, we have to keep another terms to be constant, and these laws are obtained from this. Right? This is the formula which we have derived, and by using which we have defined three laws. First law is between n and L, which is law of length, which is nothing but n is inversely proportional to L. Second law is between n and T, which is, you can see directly from the formula, is n is directly proportional to root T. Now, what two terms are constant in tension? L and M are constant. Then this n is inversely proportional to root m. You can see over here. So by using this formula, you can define three laws: law of length, law of tension, and law of linear density. So here you can see on the slide there are three laws which is given to you all. Okay, law of tension, n is inversely proportional to T when L and M are constant. Law of linear density, which is n is inversely proportional to M when T and L are constant. So we are going to prove all of these three laws by using sonometer. How? Let's see. First one is verification of first law of vibrating string. Okay, now what we are going to do is, I will just tell you by taking the slide which is of diagram here. So just look at the diagram. I will tell you whole procedure how to verify law of length. Okay, so in law of length, what we say is that n is inversely proportional to L where T and M is constant. Now for this, first you have to know what is T and what is M and what is L. Okay, so as I already told you, we have to produce resonance inside the sonometer. How to produce resonance? We are going to strike this tuning fork on the sonometer so that it will create vibrations inside the sonometer box, and the wire will vibrate and it will create resonance, and this paper rider will fall off. At that particular length, we are going to say that will be as vibrating length. T is nothing but tension which is applied to the free end of the sonometer wire. M can be measured by using mass per unit length concept. What is mass per unit length? Mass is nothing but the mass of the wire, and length is length of the given wire. So you can measure before starting the experiment. Okay, so as it is an experiment, we are going to perform it by taking number of readings, and we are going to identify whether it will satisfy the first law of length or not. Okay, for that what we have to do is we have to prove NL is equal to constant, right? For NL is equal to constant, we can take number of readings of N and even L. So let us take how to take the readings. We can take one kind of tuning fork of frequency N1. Okay, we are going to strike it on rubber pad, and then by touching the stem on the sonometer, we will vibrate the wire. Okay, and we will adjust these two pulleys. Why we are going to adjust the two pulleys? So that while we are giving the vibrations, in between the two bridges, the paper rider is there. Okay, so at certain length, which is this length A to B, at certain length that paper rider will fall off. So we are going to adjust the length so that the artificial frequency and natural frequency will match with each other, and it will create resonance, and it will give the maximum amplitude so that the paper rider will fall off, right? So by considering first reading, that is N1, we will get some kind of length L1. So we are going to record that, and we will note down the N1 L1. Okay, now again we are going to take second tuning fork. Keep in mind that either you are going to take the frequencies in ascending or in descending order. Okay, so that it will be easier you to understand the concept. Okay, so we are going to take it in descending. So as N1 is larger one, this N2 will be smaller than N1. Okay, so by taking N2, again we are going to strike the tuning fork on the rubber pad and then to the sonometer box. By adjusting the pulley at certain length, the paper rider will fall off by applying the same phenomena of resonance. The length at which the paper rider fall off, that length is nothing but vibrating length. So let us consider it is as N2. So by taking number of readings, you will come to know that the column which is NL, N1 L1, N2 L2, N3 L3, it becoming constant. Why is it so? Because it is satisfying the law of length, which is N is inversely proportional to L. As I told you that we are just going to change the frequency of tuning fork and the length between the two bridges, but we haven't touched to the tension which is there applied to the free end of the wire, right? So tension inside it is constant, and even mass per unit length, which is small m, is also constant, because we are taking the single wire on it inside the experiment. So as the column NL becomes constant, you have verified the first law of sonometer. Here it is. Now to verify second law of vibrating string, which is law of tension, what we can do is we are going to keep constant L and M. Okay, and then we are going to verify whether this N becomes inversely proportional to T or not. Okay, so by applying same kind of rule to it, we can verify the second law of vibrating string. We are going to strike the tuning fork on the rubber pad and then to the sonometer box, and it will get vibrate, and at some length it will fall off, and by using which you can verify the second law of vibrating string, which is N is directly proportional to root T. Okay, so this is as easier as that. In laboratory, that means in practicals, you are going to perform the two laws, which is first one is law of length, second one is law of tension. This both you are going to perform for the board examination. Okay, even there is a third law, which is law of linear density, which is N is inversely proportional to M. Okay, so as we already know that we are just having one wire, right? So for this law we have to consider two wires, because we have to introduce the second wire so that we can verify the third law, which is for linear density, right? So in this we will apply two, or we will require two sonometers for that. All right, by applying the same rule of resonance, we will get the third law also. So this is as easier that just remember there is one principle which is applied, which is resonance. When natural frequency becomes equal to artificial frequency, resonance occur and we get the maximum sound over there, and the peperider falls off at that length. Okay, so this is nothing but the principle which is applied to the sonometer. So I hope you got this, and if you have any query regarding this, please do comment. I will solve your query, and thank you for watching. And yes, please do write both the experiment which is given to you, sonometer law of length which is given by me, and today sir will share sonometer 2 which is law of length. You can read the procedures by which you can come to know the idea about it. Okay, while you are writing, just read aloud so that you will exactly get the idea of sonometer, and even you can observe the tables also, by looking at which you will come to know. And yes, while you are performing practicals, you have to plot a graph. Even by observing the graph, you can directly verify the laws. Okay, so even that is the plus point. While you are performing experiment, you can at a glance says about the observations of the experiments. Okay, so don't worry, we are going to perform this experiment inside lab. So if you are having some kind of queries, you will definitely resolve that queries while you are performing that experiment. Okay, so thank you so much.